To show the principle behind the circuit that we just worked, I'm going to run a simulation. Okay, so here is the simulation interface. It is from PhET, the PhET project. You can find this by going to phet.colorado.edu, look at their simulations, and look for the circuit construction simulation, DC and AC. That's what I'm using. So again, it is from phet.colorado.edu. Okay, this simulation allows you to build circuits. So in this case, I'm going to have a circuit like the one we had in the question, where we have a battery of 24 volts and a resistor of 8 ohms. Okay, so this is the resistor. I'm going to turn it around, right click, change resistance. So I'm going to change it to 8. And then I'm going to take a battery, also turn it around, and then I'm going to right click, change voltage. I'm going to set it at 24 volts. Now initially I'm going to measure these without connecting them. So I'm going to pull out a voltmeter. Okay, so this looks like the multimeter that you encounter in lab. So I'm going to put this at the positive lead. This is at the negative lead, and it reads 24 volts as we expect it to. And then I'm going to put this across the resistor. And of course we see nothing since we don't have a current flowing through the resistor. So now I'm going to take a wire and connect the battery to the resistor. Now I'm going to do the same thing to illustrate a point. Okay, so the voltmeter is here. Now I go to the negative of the battery. I still read the 24 volts. Now as I move this around the wire, I should have the same electrical potential here. So I should continue reading the 24 volts. Now since I don't have a current through the resistor, there is no voltage drop. So I still read 24 volts. Okay, now I'm going to remove this for a second, and I'm going to connect a wire from the other end of the battery. Now we have a current flow. So again, this is an ideal battery. So for an ideal battery, I still read 24 volts. I should still read 24 volts throughout here and throughout here. This wire here should have the same electrical potential, 24 volts. Now the voltage drop is across the resistance. Now the first question that we worked on the previous recording was, what if the battery has an internal resistance? Okay, so change internal resistance, and in that particular case I believe we put 1 ohm. Let's type it. Okay. Now if it is 1 ohm, look at the voltage difference across the battery. It's 21.48. It is not the 24 volts that we had initially. Let's disconnect this. I'm going to right click here, split junction. Now look what I read, 24 volts. So whenever it's in an open circuit, whenever the battery is not delivering current to the circuit, the voltage drop across the battery is the ideal voltage drop, the voltage drop that's given by an ideal battery. The minute it is part of a circuit, there will be a voltage drop across the internal resistance of the battery, so that to the outside what we see is not going to be the full 24 volts, but like in this case 21.48. To illustrate what I just said, we are going to rebuild the circuit, but now I'm going to make this an ideal battery, keep it as an ideal battery of 24 volts. This resistor, I'm going to make it 1 ohm. So this, what I have here, this resistor and battery combination, should be the equivalent of my real battery that I have here that I'm measuring. So now, if I measure it, it should read 24 volts. Now, I'm going to add another resistor that's 8 ohms, like that one. So I'm going to right-click on it, change resistance, 8 ohms. Okay, now as I have 8 ohms here, I'm going to add a wire here, make the connection, and make the connection. So you notice here, I have 21.33 volts. That's very much what I have here. There is a slight difference. I'm not sure if it is a quirk of the simulation or a small error that I make in plugging my values. But what I'm trying to say, what we have here, the combination of this 1 ohm resistor and this ideal 24 volt batteries is equivalent to, let me make sure, yeah, that's the quirk. This should have been 1 ohm. Okay. So you see I'm reading 21.33 in both ends. So what I'm trying to say, the internal resistance results in a voltage drop of 2.67 volts here. That we don't see since it's internal, since it's inside the battery. But we can figure it out by just connecting the battery to a circuit. Okay, now, let's go beyond that. What if the wires actually are real? Okay, the simulation, if I scroll down here, it allows me to give a wire resistance. It might enable me to set values here, but I'm not going to go through that right now. So if the wires have resistance, then here I have a different voltage. Why do I have a different voltage? Because I have a different current. Why do I have a different current? Because notice the voltage here, 21.97. Okay, let me just do one wire at a time. See, it drops as I go across the wire. So the battery, the ideal battery, sees a larger resistance. Larger resistance means a smaller current. Okay. And you see there how the voltage drops across the wire.